And where we ended, see, what's today? Wednesday? So where we ended on Monday is we talked about the laws of logarithms, and then we worked these four examples. Okay. And the last example we worked was simplifying this logarithmic expression. Is that what you have in your notes? Okay. And so now we're going to talk about expanding and condensing logarithmic expressions. Okay. So in the next exercise, we're going to expand the logarithmic expression as much as possible. Write it as the sum and difference of logarithms. Okay. So we're going to go from one logarithm to three logarithms. Okay, that's what we mean by expanding. And those of you who take Math 120, we had an introduction to differentiation in this class. And it's a lot easier to differentiate a function like this after you expand it than as it is as written as just one logarithm. So there's an advantage to know how to expand logarithms in calculus. Okay. So we have log base 10 of 100 times x cubed times y. And we want to expand that as much as possible. Okay. Now, you know that the input we call the argument. And the input is made up of three factors. 100, x cubed, y. Okay. From the laws of logarithms, right, we wrote out the product rule as the log of a product of two factors. Okay. Well, the product rule extends to the log of a product of several factors. Okay. And so we're going to actually be able to write this as the log of 100 plus the log of x cubed plus the log of y. Okay. But we're going to do it, I guess, in a form by induction to prove to you that you can do that. Okay. So if you have a log of like 5 factors, you can expand that log and write it as a sum of 5 logs. Okay. That's what the product rule is implying. So we have the log of m times n is the log of m plus the log of n. Okay. So I'm going to treat the product 100 times x cubed as m and the y as n. And so by the product rule, that's equal to log base 10 of 100 times x cubed plus log base 10 of y. Okay. This is m, and this is n. Well, now I can apply the product rule to the log of 100 times x cubed, right? 100 is my m, and x cubed is my n. So this is equal to log base 10 of 100 plus log base 10 of x cubed plus log base 10 of y. So I have used the product rule twice. Okay. And then I shouldn't say as a side note, okay, that when I'm expanding the logarithm, right, we got 3 rules. I find that using the quotient rule first then the product rule, and then the power rule works best, doing the rules in that order, okay? Well, what's log base 10 of 100 equal to? 2, right? 10 squared is equal to 100, right? So log base 10 of 100 is equal to 2. Now by the power rule, okay, power rule says log of m to the c power. I can bring that c down in front of the logarithm. And I have c times the log of m. So this 3, right, this exponent 3 on the variable x can be brought down in front of the log. And I have 3 times the log base 10 of x by the power rule. Log base 10 of y, can't do anything more with that. And so we have expanded this one logarithm, right? This logarithmic expression as much as possible. So this is called condensed form. When you have just one logarithm, and when you write it out as the sum and difference of logarithms, that's called expanded. So you know that when we factor, like x squared plus 5x plus 6 into x plus 2 times x plus 3, okay? These are equal, right? So this on the right and this on the left, right, represent the same thing, okay? This is unfactored form, this is factored form. The same thing here. This and this represent the same thing. This is condensed form, this is expanded form. Okay. Yes, ma'am?
Can you re-explain how you got the 2 plus 3 in front of the log?
Now, PEMDAS. Multiplication comes before addition. So the log is being multiplied by 3, and then we're adding 2, right? So log base 10 of 100 is equal to 2. Remember, okay, if the exponential x is equal to a to the y, the solution to this equation, we're solving for y. Y is in the exponent. Y is equal to log base a of x. Whenever you have to solve an equation, the variable is in the exponent, you're going to need a logarithm. Okay. So remember, when we were trying to find the inverse function for the exponential function, y equals 2 to the x, and we switched the x and the y. We had x is equal to 2 to the y. We couldn't solve for y. There's no algebra that allows you to solve for y. So mathematicians made up a function that was the solution to that equation. Okay. And that made up function is the logarithm. Okay. So 100 is equal to 10 squared. Okay. X is equal to 100. A is equal to 10. And y is equal to 2. So when I go from exponential form to logarithmic form, I have 2 is equal to log base 10 of 100. When I put x, right, 100 in for x, and 10 in for a, and 2 in for y, I have log base 10 of 100 is equal to 2. Okay. So how we got the 2, or how we knew the answer was 2 for log base 10 100 is you gotta ask yourself, right? When this is all you, if you don't know what log base 10 100 is, you gotta ask yourself, 10 raised to the y power is equal to 100. 10 raised to what number is equal to 100? 2. So that's how we got the 2 over here. Okay. Okay. All right. Well, now that we've expanded, we're going to condense a logarithmic expression. And when we condense, I find it best to apply the power rule first, then the product rule, and then the quotient rule. Although you don't always have to do the product and quotient rule in that order. Okay. So we have 4 times the natural log of x minus 3 times the natural log of x squared plus 1 plus 2 times the natural log of x minus 1. So x is the input to this natural log, x squared plus 1 is the input to this natural log, and x minus 1 is the input to that natural log. So you notice out front, right, of this natural log, we got the factor 4, here the factor 3, and here the factor 2. So the power rule says going from the right side to left side, if I have a real number times the natural log of m, I can bring that c inside the logarithm and make it an exponent on the number m. So here in this first natural log, I can bring the 4 inside the natural log and make it an exponent on the variable x. And so I have 4 times the natural log, oops, let me say that. I have the natural log of x raised to the 4th power. The power rule, now we're going to leave the minus sign here. The power rule says I can bring that 3 plus 3, we're going to leave the minus sign out here, plus 3 inside the natural log, and make it an exponent on x squared plus 1. So I have minus the natural log of x squared plus 1 to the 3rd power. And then lastly, the power rule says I can bring this 2 inside the natural log and make it an exponent on x minus 1. That's all via the power rule. Now the quotient rule says, well, from right hand side to left hand side, if I have the natural log of m minus the natural log of n, that's equivalent to the natural log of m over n. Right? The first number is the numerator, the second number is the denominator. So applying the quotient rule to that difference Now instead of using nested parentheses, I'm gonna do brackets. X to the fourth, so I can apply the quotient rule to this difference. X to the fourth is the numerator, and x squared plus 1 cubed is the denominator. Okay? So that's the quotient rule applied to that difference. And then we got to add the natural log of x minus 1 squared out here, right? We can't forget about that guy. So we applied the quotient rule. Well, last we have the product rule, right? We have the sum of two natural logs. The product rules going from the right-hand side to left-hand side says the natural log of m plus the natural log of n is equal to the natural log of m times n. This is our m. This is our n. So we multiply this quotient times x minus 1 squared. And remember, x minus 1 squared is like x minus 1 squared over 1. Okay? And so when you multiply x minus 1 squared over 1 times this quotient, you get x to the fourth times x minus 1 squared in the numerator. And in the denominator, you have x squared plus 1 cubed. That's the final answer. This is condensed form. Okay. So we went from the sum and difference of 3 natural logs to 1 natural log. So this guy up here and this guy down here are the same. They're equivalent. Okay. Any questions? Concerns? Okay. Well, looks like we should 10:25. So I'm going to give you plenty of time to take the quiz. So we will wrap this a little bit up tomorrow, okay? And then the homework will be due Friday.